Hi, everybody. Professor Nagy here. I hope you're all doing well. We are going to talk about the history of cartography today. So I'm just screen sharing. There are a lot more links. There are links in this presentation. So you can use this recording, again, as a podcast and download the PowerPoint so you can explore the links. The links take you to more information and in particular visuals, maps that we're referring to with the different things that we're talking about. So you are welcome to, again, use this as a podcast, download the PowerPoint so that you can pause or stop and explore the maps that are included in the presentation. And before I get started, I'll say history of cartography can be its own class. It could people have spent their life in a history of cartography. In particular, J.B. Harley is one of the most well-known cartographic historians. And he is going to be, he's the author of the reading that's associated with this. And it gives you a really exhaustive review of the history of cartography and the history of maps. So know that that is a complement to fill in the gaps for this presentation. So we'll move on. History of cartography. So one might say, why are we talking about a history of cartography in GIS? Well, it's because I wanted to give you a little bit of context and that maps hold really a special place in history, in particularly because maps are representations, particularly in history, of what humans have observed. And so maps have been a part of human culture for centuries. And we're going to talk about kind of the earliest maps, and then we're going to move through some significant time periods, and then we're going to talk a little bit more about how that relates to GIS today. But maps, when including countable phenomena, really are the first charts. And still today, maps are a type of chart. We don't think of them that way because we call them maps, but they really are the first way to represent natural phenomena visually. And so historically, maps tended to be more colorful and visually stimulating than charts and graphs. And so maps became a different mode of communication. They were the earliest forms of data visualization. We've probably heard that term a lot, data visualization, which is being able to graphically represent data, information points. And it was followed by the emergence of rudimentary bar and line graphs to display not only the movement and locations of the planets, but to reflect and represent developments in math and science. And so maps, you can spend a little time looking at the link associated with the title there, History of Cartography. And moving on about the earliest maps, continuing with this, and again, you can click on the links and explore a little bit more about these. That the earliest maps were of the stars, not of the Earth. And the reason being is because stars are an observable phenomena, and it could be translated to a surface for use in farming, cultural purposes, and religious purposes. And so our relationship with the stars led to the earliest maps. Maps were created in ancient Babylonian times, not on paper as we know it, but mostly on clay tablets. And it is believed that they were drawn with very accurate surveying techniques at the time. And so you're going to find that maps from kind of a generic sense are really a way of surveying. And surveying is a way to measure land and land forms. And so these maps showed topographical features like hills and valleys, but also had labeled features. Features are ways to represent physical things on a map. And so the Babylonian world map, created in 600 BC, is considered to be the earliest map of the world. And it's unique because it is a symbolic representation of the Earth. And so I recommend that you pause now and take a look at the Babylonian world map and take a look at the link associated with earliest maps to see those things. Because I think it's important to see how we have represented features, not only the stars, but land around us, and really only as far as we knew what was there. And so I think that's a really interesting aspect of in the history of maps. No surprise, we're going to talk about the ancient Greeks. they really developed the understanding of cartography as an important science for society in general. And they had a tremendous influence on Western earth sciences, including geography. And we'll talk more about some other civilizations as part of this as well. But Greeks performed scientific studies of the size and shape of the earth and its habitable areas, such as climatic zones and country positions. And the ancient Greeks created the earliest paper maps used for navigation. So again, not only this idea of surveying, but being able to use these data visualizations for navigation, being able to get from point A to point B. So not just a repository of territory that you're familiar with, but how do I get there? And these paper maps depicted certain areas of the earth that they were aware of. Ptolemy and Strabo are two kind of important names historically associated with Greek cartography. And they are credited as contributors and authors of the Geographica series. Again, these links will take you to more information about Ptolemy and Strabo, but in particular, Geographica is pretty significant. And the series begins around 1 AD, and it refers to a system of latitude and longitude. So this was the first time that somebody had put on paper, again, the science of the shape of the earth. And so this idea of latitude and longitude as navigational lines, being able to get from point A to point B, was the first time that it was being presented. As well as a means to describing locations on Earth based on astronomical observations from those areas. So again, we're bringing in the stars. Like, do the stars have the same position in the sky if I'm standing on the west side or on the east side, north side, south side, different times of the year? And so this idea, Ptolemy's idea of using a latitude and longitude system, really was a significant impact for the work of later cartographers. It kind of set the foundation. But again, prior to this, there was the Babylonian clay tablets, the Babylonian world map. So there was something to go on, but this kind of took it to the next step of adding some science to it. Moving on, again, no surprise, we're talking about the Roman Empire. During Roman times, cartographers focused on practical uses. And again, we're going to get more into kind of the surveying aspect of it. And the practical uses with respect to the Romans had to do with military and administrative needs. Administration, kind of government administration, meaning how we manage our assets within communities. And when I talk about assets like sewers, roads, utilities, things like that. Really, the Romans are credited with kind of the beginning of an administrative system, but the administration based upon military use. And so their need to control the empire and the financial, economic, political, and military aspects made it clear that the need to have maps of administrative boundaries, where does our empire start and end, physical features or road networks, was, again, the purpose and the impetus for their creation of maps. But Roman maps were restricted to the area comprised by what they call Mare Nostrum, which translates to our sea. And it's because of the prevalence of water in the region, the Roman Empire area. So since this was the core of the Roman Empire and around which all of the administrative regions were distributed. So again, what they call Mare Nostrum, our sea, those were associated with all of the maps because there was a clear observation of water. But the problem was we don't know what's on the other side of the water. We don't see the end of the water. We don't know where water starts and ends from a sea ocean kind of perspective. So moving to ancient China, early examples of cartography also come out of China. And I think this is pretty significant as well. And you can look at these links. These maps date to the 4th century BC and were drawn on wooden blocks or produced on silk. And so you can see kind of this timeline how ancient China, Romans, and Greeks are all kind of doing these things at the same time, relatively speaking, from a historical perspective. But early Chinese maps from the Qin state show various territories with landscape features such as river systems, roads, and they're considered some of the world's oldest economic maps, particularly because navigation and observable phenomena, particularly barriers, was economic information. Like, how do we get our goods and services, or our goods for trading, to the place where we want to trade? And so this system of navigation is still part of map use, map creation, map impetus. And it continued to develop in China throughout its various dynasties. And one of the most significant, in 605 AD, an early map using a grid system, which again is associated with surveys, was created by Pei Zhu of the Sui dynasty. And in about 800 AD, the Haine Hua Yi Tu map of both Chinese and barbarian peoples within the 4 seas, that's the English translation, was created by the Tang dynasty to show China as well as its Central Asian colonies. And this was a pretty significant map, 30 by 33, and it used the grid system. So I want you to take a look at that because it has a really accurate scale. And I think that, again, as we're starting to see kind of the science behind what we're representing and what we see and interpret in our mind, and putting some science to it as to, are these accurate measurements, what measurements are used, and it's going to vary the type of measurement, or the linear measurement systems are a little bit different, but again, using some sort of representation of reality. And so our understanding of reality starts to increase with the use of maps. Can't leave out the Arabic maps and the Arabic contributions. Al-Idrisi completed several geographic contributions, and namely these things you'll learn about. A silver planisphere on which was depicted a map of the world, a world map consisting of 70 sections formed by dividing the Earth north of the equator into 7 different climatic zones of equal width, which was then subdivided into 10 equal parts by lines of longitude. So again, we're using science and starting to understand our world, and now we're getting a little bit more specific in terms of, how do I break these into different zones, these different areas? Are they mathematically correct in terms of our representation and what we understand those places to be? And lastly, a geographic text intended as a key to the planisphere. And this is known as the Book of Roger. I cannot pronounce it in its native tongue, so I did not include it here. But the English translation, the Book of Roger. And in compiling it, Al-Idrisi combined material from Arabic and Greek geographic works. So again, we're talking about Cartographica and Geographica, works with information obtained through firsthand observation and eyewitness reports. So again, this is still representation. And when you firsthand observation, what they can see based on where they are, and then being able to wrap in eyewitness reports, people that had traveled and can report back as to, how long it took to get to through their travels, the distance, the physical features that they encountered, as things to include on these maps for people to use moving forward. And then we move to kind of medieval times. And in around the 13th century, the Majorcan Cartographic School was developed in Europe. And the school, even though it wasn't like a school, but it was more of like a learning center, was a collaboration of mostly Jewish cartographers, cosmographers, again associated with the stars, navigators, and navigational instrument makers. And so the Majorcan Cartographic School invented the normal Portolan chart. And it was a nautical mile chart that used gridded compass lines for navigation. So again, our latitude and longitude, the purposes of navigation are important to note here. Around the 1500s, late 1500s, the Guang Yutu Atlas was produced. That was Chinese, and it contained over 40 maps that used a grid system and showed major landmarks like roads and mountains, as well as the borders of different political areas. So again, we're seeing how maps are becoming more refined, more specialized. Not everybody can do it, but a special attention paid to being able to produce data visualizations and charts that assist others with political, administrative, navigational, and discoveries to include as new information that we know. And we moved to the age of exploration around the same time. Cartography developed further in Europe during the age of exploration. I mean, that's why it may not have thought of it this way, but the age of exploration was really about, you know, where are we going and how do we represent those things? I mean, there's more to it than that, clearly, but why else would it be called the age of exploration? And so as cartographers, merchants, and explorers created maps showing these new areas of the world that they visited, or again, through eyewitness reports. In the early 1500s, the first maps of the Americas were produced by Spanish cartographer and explorer Juan de la Cosa, who sailed with Christopher Columbus. And in addition to maps of the Americas, he created some of the first maps that showed the Americas together with Africa and Eurasia. So again, starting to kind of experience the world around us as we're, I just say we as a human race, starting to learn more about what's going on in the world around us. And throughout the rest of the 1500s and it's the 1600s and 1700s, further European exploration resulted in the creation of maps showing various parts of the world that had not been mapped before. And these are things I think what's important to note here is what hasn't been mapped, right? So I think that there exists a lot of opportunities to still ask those questions. What kinds of things haven't been mapped? How do we do it? Do we do it the same way? And at the same time, as the map territory expanded, cartographic techniques continue to grow in their accuracy. Again, as technology is introduced, we do better. We learn more, and we're able to observe that phenomena, represent it in a more clear and accurate way, which then assisted those that were users of this information. And we're modern cartography, again, you know, 1700s on. So consider that, you know, 1700s modern in relative terms, thinking about kind of the history that we're talking about here. And it began with the advent of a variety of technological advancements, which I mentioned just now. The invention of tools like the compass, telescope, the sextant, quadrant, and printing press all allowed for maps to be made more easily and accurately. And as new technologies develop, it also led to the development of different map projections that more precisely showed the world. We'll talk about projections and coordinate systems in a later talk, but a projection is projections are a way to take a round surface and project it onto a flat surface. So we take a globe and we flatten that out, and you get a lot of different things that happens to something, right? So if you take the most widely known example is, you know, peeling an orange. So when you peel an orange and you're able to keep the skin intact, you can't flatten it out without there being some sort of rips and tears in that orange peel. And so, you know, what happens to those places that peel and tear along the edges? That is kind of the philosophy or the theory behind a projection, is when you're flattening out the globe, the Earth, flattening it into a two-dimensional surface, that there are things that are going to be distorted. So in the 17th and 18th centuries, the United States Geological Survey and the National Geodetic Survey used new tools to map trails and to survey government lands. And moving right along to the 20th century, the use of airplanes to take aerial photographs changed the type of data that could be used to create maps. Now we have something more accurate than somebody visually observing it from their point of view, but rather photographs, legitimate information. Satellite imagery has since become a major source of data. We use it today, and it is used to show large areas in great detail. And then finally, GIS is relatively new in that it's changing cartography today because it allows for many different types of maps using various types of data to be easily created and manipulated with computers. I have to pause for a minute here. Also, I think it's important to mention a kind of specific well-known case of how we started to use maps, and that this early example of the power of mapping comes from the famous Dr. Snow investigation. And this is in the mid-1800s, and during an outbreak of cholera in a section of the city of London, Dr. Snow, a local physician, decided to test his hypotheses that the outbreak was a result of contaminated water supplies. And that view was contrary to the medical beliefs of the time. They thought it was airborne. Cholera was caused through airborne virus bacteria. He accomplished this by drawing a map showing where the victims lived and where the local water pumps were located. And he plotted the location of the homes of almost 600 people that had died of cholera, as well as the position of 13 neighboring water pumps or wells, and is theorizing that cholera was a waterborne disease rather than an airborne disease. And in examining his map, he determined that most victims lived in the vicinity of one specific water pump. And the map clearly showed a clustering of cholera cases around one of the pumps. And when that pump was shut down, the outbreak stopped. And so using the simple means of pen and paper and making a map, and it didn't necessarily have to do with latitude and longitude and those kinds of things, but really representing phenomena on a map. He was able to prove a cause and effect relationship between a contaminated supply of water and instances of disease by using a map to visualize these instances of disease in the location of water pumps. That is kind of the first way of thinking of spatial analysis. How close or far are things and what kind of relationships do they have? And then we have mapping today. So mapping today is rarely in print. Really the only print maps that you're using, and sorry about my dog back there, in print, we have lots of digital maps. Very rarely do we have paper maps that we're using. However, our historical maps are in print and they are available digitally as well. But today, you're rarely using print maps. You may print out a poster map or something like that to take to a public meeting or some sort of presentation. Nowadays in pandemic times, not so much, but mapping has gone digital and therefore it's become more universal. And I think that's an access message, and that more people can access this information now than ever before. And mapping now is no longer just about geography. It's about the characteristics of people in those places as well. So not only are you looking at geographic information, but you're also looking at patterns of behavior, both with people and other instances, to be able to look at the relationship between those things. And so mapping continues to be improved by technology and innovation. That is also part of this class, learning QGIS. QGIS is now the leading open source GIS software, fairly recent, again, in relative terms, but a growing competitor to proprietary GISs. And maps visually supplement research, but it's also a research methodology. So not only are you using maps to say, hey, I'm trying to describe this particular phenomena, and I'm going to use this map as a way to kind of prove my point, but you can also use spatial analysis as a research methodology. So just like you have quantitative and qualitative research methods or mixed methods, GIS is its own research methodology. I am using GIS and these particular geographic information system methods or spatial analysis methods to study this problem. And spatial thinking is not necessarily a natural trait, but it's a learned skill. And I say that because we may not know that we're part of phenomena. We may not know that we're looking at phenomena. And so the more practice that you get at looking at maps and seeing the different kinds of things that are mapped, it improves your spatial thinking skills. You know, how close or how far, duration of time, directionality, things like that. And so we just talked about spatial thinking. And so this is kind of one more layer on that is it's not always a natural trait, but it's something that can be learned. And so if maps and map reading in particular is something that you've struggled with or you never really thought about, we'll be doing some of that too. I think that's the, at the end here, I have a TED Talk video. I like TED Talks. I like the ideas that they present. And the name of this particular talk is Making Sense of Maps. And it was done in 2012, so a little dated, but again, the ideas are still applicable. And so this gentleman, Aris Venetikidis, is fascinated by the maps we draw in our minds as we move around a city. Less like street maps, more like schematics or wiring diagrams, abstract images of relationships between places. So again, our representation of what we understand the circumstances to be. And how can we learn from these mental maps to make better real ones? So mental maps, the ways that your brain is making sense of the arrangement of things around you, the geography, the dimensions, the directions, the orientations, and you can make your own mental maps. And mental maps count within the sphere of cartography as well. It may not be mathematically accurate, but it is an abstract image of relationships between places and how we understand those things. So there's still a human element of representation. And so I hope you enjoy the video. Again, the reading is a pretty long reading. J.B. Harley is a well-known as kind of like the cartographic historian, particularly in the United States. I ask you to do a reading and pick out some things that you think are interesting. There are a lot of interesting things that you'll read in this particular piece, namely that maps really are a form of communication, and maybe you didn't think of it that way. But what I'm asking you to do is to select 3 points from the article that you think are most relevant, important, interesting, and to post them on the discussion board. So it's not a terribly, the assignment isn't too difficult. It's really more of an exploration and a review of this cartographic history as a supplement to this talk, because as you can see, I gave you kind of big picture things and kind of chunks of time and how they relate to cartographic history, but this gives you a little bit more in-depth view and perspective on the history of cartography. And so I look forward to seeing your responses to that, and I look forward to talking to you next time. I'm gonna stop the recording here.